In this lesson, we're going to talk about how to graph curves that have oblique asymptotes. Suppose we want to graph the curves shown. Well, we see that we have a vertical asymptote at x equals 5 because x minus 5 is a factor of the denominator and doesn't cross out when we simplify. After simplifying, we have degree 2 over degree 1, which tells us that we're going to have an oblique asymptote. So we'd like to know what the equation of the oblique asymptote is, and in order to do that, we determine the division statement of the rational expression. So dividing x minus 5 into x squared minus 6x plus 6 gives us the equation y equals x minus 1 plus 1 over x minus 5. Well, y equals x minus 1 is the equation of our oblique asymptote. Now let's determine the y-intercept. Well, to do that, we simply let x equal 0, and when we evaluate y, we get negative 6 over 5, so there's our y-intercept. To determine our x-intercepts, we let y equal 0, and in this situation, we are going to have to use the quadratic formula, and we determine that x is equal to 3 plus or minus root 3. So for purposes of graphing, it's helpful to have decimal approximations to draw a good graph. So we have 1.3 or 4.7. All right. Now let's do a vertical asymptote analysis. We're not going to do an epsilon analysis in this situation, although theoretically we could. Let's let x have a value 0.01 to the left and 0.01 to the right of any x values of vertical asymptotes. Well, our vertical asymptote is at x equals 5, so we're going to let x have values of 4.99 or 5.01. Letting x have a value of 4.99, we get a y-coordinate of negative 96.01. That tells us that the point 4.99 negative 96.01 is on the curve. What that tells us for our graphing purposes is that to the left of the vertical asymptote, y is going to negative infinity. When we let x equal 5.01, we plug in for y, and we get a y-coordinate of 104.01. Well, that tells us that to the right of the vertical asymptote, y is going to positive infinity. Now, let's do an oblique asymptote analysis. This is going to be kind of similar to a horizontal asymptote analysis, where we're going to let x equal negative 100 and see what y equals. Well, when we let x equal negative 100 and plug it into the function expression, we get a y-coordinate of negative 101.01. That tells us that the point negative 100, negative 101.01 is a point on our curve. Okay, good enough. Now let's compare that to the oblique asymptote value of y. In other words, what does y equal if x is negative 100 and we're plugging it into the oblique asymptote expression? Well, when we do that, when we plug in an x value of negative 100 to the oblique asymptote expression, we get negative 101. So that tells us that the point negative 100, negative 101 is on the oblique asymptote, whereas the earlier point that we determined is on the curve. Well, an x value of negative 100 is to the far left, and that tells me that the y-coordinate on the curve is slightly below the y-coordinate on the oblique asymptote. That tells me that the curve is approaching the oblique asymptote from below to the far left. Okay, let's let x equal 100. That's to the far right. When we let x equal 100, we get a y-coordinate of 99.01 on the curve. Well, when we let x equal 100, we get a y-coordinate of 99 on the oblique asymptote. Remember, the oblique asymptote is simply the line y equals x minus 1. Well, what that tells me is that the curve, when we're to the far right, the curve's y value is slightly greater than the oblique asymptote's y value. That tells me that the curve is approaching the oblique asymptote from above to the right. Okay, so it was approaching from below to the left and above to the right. Now, that's a plug in the number kind of way of doing it. Another way of doing it, which is really interesting, is this. This is a second version of an oblique asymptote analysis. What we can do is look at the entire division statement. We have y equals x minus 1 plus 1 over x minus 5. Well, that could be interpreted as saying y is equal to the oblique asymptote value minus a small quantity. Oh, sorry, this is to the far left. If we're to the far left. So, in other words, if we were to the far left, a number that's quite negative, 1 over x minus 5 would be quite negative. So, x minus 1 plus that quite negative number would be like saying y is equal to the oblique asymptote minus a small quantity. So, to the far left, our y value would be slightly below the oblique asymptote. Let's take a look to the far right. If that wasn't clear, we'll take a look to the far right. Suppose right here, we let x be a number far to the right. Okay, well, we know that our equation of our curve is y equals x minus 1 plus 1 over x minus 5. Well, if I'm letting x be a number to the far right, this is going to be positive. So I'll be saying x minus 1 plus something. Well, that could be interpreted as saying y is equal to the oblique asymptote plus a small quantity. Putting both of those together, we could say that as x approaches negative infinity, the function, remember, is equal to the oblique asymptote minus a small quantity to the far left. So we could say the function approaches the oblique asymptote from below. But to the far right, we saw that the function was equal to the oblique asymptote value plus a small amount. So we could say that as x approaches positive infinity, the function approaches the oblique asymptote from above. Okay, well, regardless of how we do our oblique asymptote analysis, we're going to be able to come up with certain ideas. We saw our vertical asymptote analysis gave us those arrows. Our oblique asymptote analysis told us that our curve was approaching from above to the far right and from below to the far left. We got this y coordinate and these two x coordinates, and putting all that together, we can draw ourselves a decent curve. Okay. Let's try this next one, x squared minus 4x plus 2 over x minus 1. Well, we can't simplify the numerator and our denominator of x minus 1. We're not able to simplify that out. So we have a vertical asymptote at x equals 1. We do our synthetic division, and we get a division statement shown here. And that tells me that my oblique asymptote is at y equals x minus 3. All right, well, we figure out where our x-intercepts are. We have an x-intercept at y equals 0. When I evaluate the x-intercepts, when I let 0 equal x squared minus 4x plus 2, I get a couple of different y values here. It's good to come up with decimal approximations just for the purposes of graphing. And so we got a couple x-intercepts. We're also going to let our x equal to 0 and determine our y-intercepts. We're going to get a y-intercept in this case at 0, negative 2. Now we're going to do a vertical asymptote analysis. We're going to let y be a number slightly to the left of x equals 1. Letting y equal 0.99, we get a very significantly positive number, telling us that as x approaches to the left of the vertical asymptote, y will approach positive infinity. And similarly, we'll see over here that when we let x be a number slightly to the right of the vertical asymptote, we get a quite negative number, and that'll tell us that as we approach the vertical asymptote from the right, y will approach negative infinity. Okay. Now let's look at our oblique asymptote analysis. The first method, we'll do the first method and then we'll do the second method. Letting x equal negative 100, we get a value of negative 102.99. What that tells us is that the point negative 100, comma, negative 102.99 is on the curve. But the oblique asymptote is y equals x minus 3. So we know that the point negative 100, negative 103 is on the oblique asymptote. Well, what that tells us is that since negative 102.99 is above a negative 103, that tells us that as x approaches negative infinity, the curve approaches the oblique asymptote from above. But as if x is 100, we see that the y coordinate is 96.99. Well, that's a point on the curve. A point on the oblique asymptote would be 100, 97, and that would tell us that to the far right, the curve is approaching the oblique asymptote from below. Now we could do it that way, or we could look at focus. We could focus on method 2. Just look at the part of the division statement that said minus 1 over x minus 1. Let's go back to that division statement, which was right here. Recall from the bottom that our division statement was y equals x minus 3 minus 1 over x minus 1. Well, if we focus on just the part that said minus 1 over x minus 1, we see that if we let x be a number like negative 100, we'll have 1 over negative 100 minus 1. And this is overall a positive value. So what that tells me is that to the far left, then the amount that I'm adding to the oblique asymptote is positive. So that tells me that to the far left, the curve has a slightly greater y value than the oblique asymptote, telling me that to the far left, the curve approaches the oblique asymptote from above. But to the far right, again, remember the part that we're adding to our oblique asymptote from the division statement is negative 1 over x minus 1. To the far right, if I plug in a number like 100, this is going to be a negative number overall. Well, that'll tell me that the y-coordinate of the curve is equal to the y-coordinate of the oblique asymptote minus a little bit, which would tell me that as x approaches positive infinity, the curve is approaching the oblique asymptote from below. However we think of it, we're able to put all of our information together. From our vertical asymptote analysis, we got these two arrows. From our oblique asymptote analysis, we got these two arrows. Earlier, we found out our y-intercept and our two x-intercepts. So the only curve that really fits and makes sense is that one. Okay. Suppose we want to graph this curve. We got a cubic over a quadratic. Looks pretty difficult at first, but then we realize that we can factor x minus 1 out of both the numerator and denominator. And so when we factor x minus 1 out, we're able to cross it out. And we have a quadratic over a linear that doesn't simplify further. Because of the way we simplified, we see that we have a whole at x equals 1, but we have a vertical asymptote at x equals negative 2. Okay, well, it's good to know the y-coordinate of the whole, so we take the x value of 1 and plug it into the, we take the x value of 1 and plug it into the simplified expression for y, and we get a y value of 10/3. That tells me that we're going to have a whole at 1, 10/3. Okay, so let's forget about the whole for now, and let's just go about this as though we have a quadratic over a linear. When we do our synthetic division, we see that we end up with an oblique asymptote of y equals negative x plus 5. Okay? Well, we can now determine the x-intercepts. To do that, we let y equal 0. And it turns out that we get x-intercepts at these values right here, irrational numbers. We can use our calculator to approximate them for graphing purposes. To determine the y-intercept, we can let x equal 0. Letting x equal 0, we get a y-coordinate of 4. And that tells me that the y-intercept is at 0, 4. All right, so now what we can do is do our vertical asymptote analysis. When we let x equal a number slightly to the left of the vertical asymptote, we get a significantly positive y value, telling us that to the left of x equals -2, y approaches positive infinity. But when we let x be slightly to the right of the vertical asymptote, we get a significant negative value, telling us that to the right of x equals -2, y is approaching negative infinity. Now we'll do our oblique asymptote analysis. If we let x equal -100, we see that y is 105.2. But when we let x equal -100, we see that the y value of the oblique asymptote is 105. Well, that tells me that as I'm going to the far left, the curve is approaching the oblique asymptote from above. Okay? To the far right, if I let x equal 100, I see y is -95.02. And if I let x equal 100, I see that the y value of the, if I let x equal 100, the y value on the curve is -95.02, but the y value on the oblique asymptote is -95. That tells me that as x goes to positive infinity, the curve is approaching the oblique asymptote from below. That's one way of doing it. Another way of doing it is simply to focus on the part after the oblique asymptote in the division statement, and that part is -2 over x plus 2. Now, if we give x a negative value as we approach negative infinity, we're going to get a positive value overall out of here. We'll have a negative in front of a fraction that has a positive numerator and a negative denominator. All in all, that'll be positive, which would mean that as x goes to negative infinity, y will be approaching the oblique asymptote from above. But if we let x have a significantly positive value, then -2 over x plus 2 suddenly becomes a negative quantity, and so our curve will be approaching the oblique asymptote from below. So putting everything together, we remember that we knew the direction of these arrows from our vertical asymptote analysis. We knew where these arrows went from our oblique asymptote analysis. We remember that we had a couple of x-intercepts, we had one y-intercept, and we even had a little hole here, which you don't want to forget about.